What is up, guys? Today we are building something very interesting. You see my server is running and I've opened up my localhost 8080 out here. This is a full stack project that uses Rust, and it uses the Tide framework in Rust, which is an awesome framework. It has a lot of functionalities, but it's also very lightweight, very easy to get started with, and a very small learning curve, very short learning curve. So this is why we'll be learning Tide today, and we'll be using Postgres. So this is a complete CRUD API which has Tide and Postgres, and for the front end we're using something called as Terra. We've already seen how Terra works, so we built the Actix 3, the Actix Web 3 project on my my Rust playlist also with Terra. Okay, now this is how it works. So this is like a complete CRUD application, like I said. So let's say Megalosaurus. So you can add different types of dinosaurs here. Dinosaurs. So I'll say 2,000 kilograms. Diet is vegetables. Okay, and submit. So I have a new dinosaur, and I'm going to say this as 4,000 kilograms. Diet is meat mostly. And now I have two of these. I can edit these as well. So I can say just grass. Okay, and I can see the change there now, and then I can also delete one of these. So it's a complete CRUD application, like I said. Now I quickly wanted to tell you about the fact that this code is on my GitHub, so make sure you start it so that you can find it later on. It's called Rust Tide Postgres CRUD, and I'm Akhil Sharma 90 on GitHub. And yeah, so we're using Tide, SQLX, Postgres, and Terra. In today's video, we're going through the entire code. So if you want to fork this or clone this, make sure you do that. And you can also run this project, and then I'll explain to you how this project works so that you can truly make this your own. You can add this to your own portfolio, show it to your future job, you know, the company you're applying to, whatever you want to do with this. But yeah, I'll explain the entire project to you, but make sure you just fork it or clone it, and then you have it installed on your personal machine. But I've also given you the instructions on how to run this. So you need to have Postgres installed, and you need to have a database called Tide in your Postgres. Now, apart from that, you also need a table called dinos in that database called Tide. So in case you don't know how to work with the schema.sql file in the project, you can run this command directly. I've given you the command, just run this, and you'll have the dinos table directly in the Postgres DB. Okay. I've also given you the sample.env file. So if you see here, there is a sample env file here, and that has the database URL. In my case, I'm running it on localhost. You could be running it on another server, or it could be in Docker, but again, that'll also be localhost. And here you have the Tide secret. I'll talk more about that in a while. Then we have our OAuth client ID. We have the OAuth client ID because we have login with Google. Okay, so I can click on that, and this will open up login with Google. All right, where's English? Yes. So you have login with Google as well. And yeah, and before we get started, just want to tell you that this video is going to be part of the 50 Rust project series on my channel. And because this is slightly like somewhere in the middle, it's not too difficult, not too easy, so it'll be somewhere in the middle, because these projects, I'm trying to arrange them in the level of difficulty. So the idea is anybody who wants to learn, they can just start with the projects, and then at the end they'll be a great Rust developer. And similarly, on my channel, I also have 54 killer Golang projects. If you wanted to learn Golang by building projects, this is the best place to be learning from. Then I have the AI and LLM projects, quite a few of those as well. I'm adding more and more every few days. Then I have the Ultimate System Design and Technology Architect course. So these are the courses that I recommend you do on my channel. Make sure you subscribe, and make sure you share this with your friends, because that's completely free, right? You're getting so much value completely free. All right, so now let's get started. Let's start going through the code together. So I'm going to open up my VS Code, and let's do that. First, let's go over the project structure. So we have our src folder, which has all of our logic, and we have two folders inside, controllers and handlers, and our main.rs file. So we have mod.rs for each. So for the handlers, we have our mod.rs, and controllers, we have the mod.rs, which is listing out all the modules that we have. For example, in the controllers folder, for example, we have auth, deno, and views. So we have auth, deno, and views. Now views is responsible for rendering the Terra templates. So these are all the functions. So for example, the index function, then we have the new function, then we have the edit function, and all of these are responsible for rendering some sort of a Terra template. And all of these templates like form.html, index.html, and layout.html have been created already for you guys, so you don't have to like do anything, like worry about too much. Everything is here. So I've created all the the HTML files for you guys, and all we have to do now is just render them with the help of Rust and Terra. Now in our main.rs file, we are using all the usual suspects, right? So we have Serde, which we have learned about in this series extensively. It's serialization, deserialization. We've learned about SQLX, which will, in this case, is helping us to work with Postgres, and we'll be using the pool to work with, to create a database pool. We're using Terra for the front end. We're using Tide, the server framework, to help us create all these routes. We have UUID, we'll soon see why. Then we're getting the controllers and the handlers, these two modules. Then we're getting specific like auth, Dino, and views from the controllers module. Okay, coming back to the main file. Now we have a little bit of OAuth 2 related work, which I will get into in a while. But first, let's cover the basics. The first is the state of the front-end application. One is the DB pool, the Terra, and the OAuth client. Then the struct for the Dino itself. So we created a dinosaur I showed you on the front end. So it took a name, the weight, diet, and so on, and the user who's creating it. So we're storing all of this data in a struct called Dino. In the async main function, we are first loading the .env file that we have, right, where you have to put in all the details for your database and your, so for example, the database URL and the tokens for your Google OAuth application. But in this case, let's work first with the database URL. We're getting that in this variable called db_URL. We are also starting a Tide log server, which is the middleware for logging. And we're expecting the database URL to be there, otherwise we'll say missing database URL environment variable. We also have our port variable, so we have port 8080 and our DB pool. Now DB pool is a variable that calls in the make DB pool function, which we have out here, and we're passing in the database URL, which we've recovered from the environment file for the database URL constant. Okay. Then we'll create an application which will call the server function. So we have the server function defined below here. So we're calling the server function here in our main function, and we're passing the DB pool to that. And then we create a listener for the app on localhost. Port is 8080 as we've defined out here, which is the standard 8080. And then we're listening. Basically our server is listening. Now let's check out the make DB pool function. Nothing happening here. We're using pool, which we got here from SQLX, and we are just connecting with the database URL. That's about it. The most important function here is the server function. Takes in DB pool, which is PG pool, and returns the server state. So we start with Terra, and we define Terra with capital T is defining we're like extracting a new function from there, and it's helping us create define the templates, right? So if there was no templates directly found, in our case there is, but if there was no templates directly found, it'll be an error. But we create a new Terra client here with the help of Terra new function and these templates, and we initialize the state being the struct that we just created here on top, which is the DB pool, Terra, and OAuth client. It has those three things. And then we have our Tide with state. So we start our Tide application with the state struct, initialize state struct. Now the most important thing here obviously are the routes that we have to define, because that's why we're using Tide in the first place, to start a server and to define the routes. And here we're starting a Tide session with a Tide secret. Tide secret is an environment variable that's already been defined by us. So you just have to, it's there as part of the sample.env file also, you'll find it. So you just have to write any random text there, and I think I've kept a text already there, so you can use that as well. So here are all the routes. So first at the root route, we want to render the index.html template. If you see here at the index, this is the welcome template. So I'll say welcome username and all of the things like the list of all of the dynos in the database. So so at the root we will render that, and then if somebody wants to create a new dyno, we will send the user to /dyno/new, and that's the API that will be called, and then the new view will be so we have in our views folder, we have the new function, out here. So that's the one that will be called. So here, even from main.rs, right, when you saw that the root route was being called, so here also we're calling the index function, which is essentially calling the index.html. So I talked about the index.html directly. I should have told you that we call an index function, and that's how we render the index.html. All right, now going back to the main.rs, and then you have getting a particular dino to edit the value, or the value of it. So that's where we'll open up the edit page. And similarly for OAuth, we have Google, and we have the logout route, and then we have our showing our list of all of the dinos that exist in the database. So you have /dinos, and you have the list of all the dinos, and then get dino by ID. So you can get the dino by ID, you can edit it or you can delete it, and then the public directory is defined that as well. So app is the server that this function returns. The server function returns the app with the state, the server with the state. And then I've written some tests here which you can use or remove, depending on how you like it. I've created some tests for you, but the program, the testing also works in the same way that we have used the program. So now the next folder is the handlers folder, and handlers folder is having all these database related functions. So that means that from our main.rs we're actually calling our controllers, all of the controllers. So the dino which are in dino.rs, like for example the create function and the list function, the get function, the update function, the delete function, and so on. So if you notice carefully, we are calling all the like the create function, the get, update, and delete function from dino, and this is the dino that we're talking about, the controllers dino. So we have all these functions here, right? So create function basically helps us create a dino object. But let's go over it line by line. So what's really happening in the create function in the controller? So just again, one very important thing to remember is from the main.rs file we call the controllers, and from the controllers we are calling the handlers. So let's go over the flow again. So we are right now in the controllers, in the create function of the controllers, and what we do here is we get the body JSON from the request. So request will have the complete body for the new dino that we want to create, right? So, or dino, however you want to pronounce it, right? So you get that in this variable called dino. You create a database pool, start a new session, it will be in the request.session, and then match the session to the user ID. And essentially, the main thing that you're doing in this entire function is this, which is you're essentially just calling the dino create function of the handlers. So in the handlers, when you go to dino.rs file in the handlers, you'll see this create function, which is where the actual talking to the database is taking place. So in the controllers, all you're doing is just like forwarding the body and all of that stuff to this function. That's all that you're doing, okay? The DB pool and the body. So that's the only thing that you're doing here. And you get back the response, and then you set the body response for the front end. That's all you do in the controllers create function. Similarly, in the controllers list function, you again work with the DB pool, and all you're doing is calling the handlers dino list function. So in dino, there is a list function that we look at properly, but that's the one that's being called along with the DB pool, and then you get back the response, and then you set the body for the response and return back the response. So that's what happens in the list, and also in the get function. So again, you have your request state, and then you have your ID, which will be in the param. So you're getting the a particular dino by ID, and you're going to call the function get with ID and DB pool. Now, the difference between get and list is returning all of the Dinos in the database, and get is getting a Dino with the help of a particular DB, particular ID, and you're passing the DB pool again. You're using the UUID package to parse the param ID, and you are then getting the response, setting the response and returning that. If there was no response, you're just returning a 404 error, because if the Dino with that particular ID doesn't exist, you will obviously return a 404 error. And finally, returning the response that you've created here, which is the body. Now, the update function and the delete functions are the ones that are left in our controllers file. And I quickly want to digress. I just want to tell you about the 6 AI plus Golang projects course that I've created on Gumroad, and it is 26 hours of awesome killer content, and we're only building AI projects with Golang here in this course. So it's 2024, and if you're looking for a job or looking for a pay upgrade or something like that, then AI is going to be the most important thing that recruiters are going to be looking for. Or if you're applying to a startup, then that's the most important thing the founders are looking for, because everybody's upgrading their products with now and including AI in their products, right? So here you learn to build 6 AI products. You build a AI Discord bot, API bot, a Whisper API bot, which is speech to text. You build a Telegram AI bot, a Kubernetes AI assistant, Terraform AI Copilot, and a very powerful and comprehensive terminal AI assistant, a full-blown AI assistant and powerful terminal tool. So like I said, 26 hours of detailed content and extremely detailed planning exercise for each project. So I've given you password protected files which have the planning exercises for each of these projects. You have well-documented code. Each line of code is explained, and all of these projects are important, real world and high value projects. So make sure you check this out. The link for this project, for this course, is in the description of this video. Now, going back to the code, to our update function from the controllers, what we do is we are getting the request in this function, accepting that as a parameter, returning back the result. We start with the Dino request body, and then we create the DB pool. We get our ID from the request object. We create we check for the session for the user ID, and then we are essentially calling the get function first. So we're calling the get function from our handlers dino.rs file, calling the get function from there. And because when you update, right, you first check if that particular item even exists, and you fetch that particular item, and then you update it. So you get that particular item, and then you call the handlers update. So all that you're doing in the controllers is actually just calling functions from the handler. So you call the get function from the handler, you called then the update function from the handler with the ID and the new body and the DB pool, and then you got back the response. If there was no response, then you'll send back 404. Otherwise, if there was a response, you'll create that into the body and return that response. Delete takes in an ID, right? So it'll be there in the request ID parameters. So we'll get that ID, because you want to delete by ID, you want to delete a particular Dino. So that's why you get that by the ID, and then you have your request session for that user ID, and then you are just calling the get function first, and then you're calling the delete function. So delete function in the handlers, right? So first you have to get the function, you have to get the particular value to see if that value even exists in the database for that particular Dino, for that particular ID, So if it doesn't exist, then you can't delete it, right? So if it exists, you fetch it, then you delete it like this. And then you send back the response saying that, hey, everything was deleted. Now, as we have noticed that a lot of the stuff is happening in the handlers dino.rs, because these are the functions that are being called from the controllers. So we'll take a look at those. But I quickly want to just take you over views.rs. So what's happening here is, like, this is the index function, and the job of the index function is to render index.html. That's all that's happening. That's all that is happening here. But we're doing all, like, a little bit of the plumbing stuff, which is required, like, for example, the Terra state, and then the DB pool, and then, calling the list function from the handlers, because that's how you'll display all the list of the complete list of the Dino, right? So when we're rendering the index.html page, when we hit the slash or the root route, that's when we want to call the handlers Dino list function, which we just saw, and the handlers Dino list function, as you now remember, is calling the is directly here, which we're going to take a look at directly. So we're calling the handlers Dino list function, and we are displaying the list of all of the dinos. And then we are just rendering index.html, and we are also getting the title, right? If you remember, we have like a table, so it has a title and the dinos, which are all the rows basically. The user ID and the username are also being kept in the context. Now the new function is supposed to render only form.html, right? That's what it, because when we're creating a new dino, we have something called as a form.html, which basically accepts the values for the dino. Okay, so right, for example, here we have name for the dino, the weight of the dino, the diet, and the button which is submit. So we have so we're just rendering that. So, and we have all the plumbing stuff, which is the Terra, the session, the user ID, and then we just keep this in the context. Then for the edit, you again would want to render form.html, but you'll have all these values, like for example, editing that particular dino. So that's why we want to render that with the row and the user ID, because we want to save that for the user who's changing this. And then you have your regular plumbing stuff, which is Terra, session, and user ID, same here, and your DB pool, your ID of the particular dino that you want to update, and then you're basically calling the get function from our handlers to get that particular dino, because you want to show that to the user and then you want the user to edit it, right? That's how we did it in the demo as well. And then you are creating a response, nice little response body, and also rendering the form with that data, and then you're basically setting the body with that and then sending that as the response. So that's what's happening in the views.rs. Now finally to where everything is happening, which is the handlers dino.rs. So here you're getting all of these things, which is your dino crate and your SQLX, because you're working with going to be working with Postgres in this particular file. And if you remember from this controller, the dino.rs file in the controllers, the first thing we call is the create function in the handlers dino, right? So that's the create function. You're getting in dino, you're getting in db pool, and you get giving back a result which is of type dino. And this is what is happening. You are inserting into dinos. This is like your Postgres command, inserting into dinos ID, name, weight, diet, user ID, and these are the values. So when you say $12345, these are the values that are going to be replaced out here for $12345. So returning the ID as ID, name, weight, diet, user ID, and then you have the ID, name, weight, diet, and user ID, and then you just fetch one DB pool, and then you make that happen. Basically, run this command in the database, and then you have your listing command, where you have select ID, name, weight, diet, user ID from dino. So it's going to basically return all of the dinos in our database, and that's the list command that we're running. And just as a quick revision, we're calling the list command from the list function, from the list function in our controller. So we're calling the list function in handlers from the list function in controllers. That's how we're doing it. And then we have our get function. So we have pub async function get, and we have our ID and DB pool, right? So we create, we select ID, name, weight, diet, user ID from dinos, where ID is $1. $1 basically is getting replaced by ID. So we're getting a particular dino by ID, which ID has been passed here in this function. And that's the one that we return here. So we return the row here, and that's the one that we're using here in the get function. So you're calling the get function here. Now the get function is not just called here in the get function of controller, it's also being called in update and delete, if you remember. Right, so we're calling it in the update as well as in delete. Okay, so just remember that this function is a bit important. It's being called into 3 places. And then you have finally the delete and the update function. So delete function, delete from dinos where ID is $1, which is this ID, and so you just delete it. And similarly update with the new data, which is dino name, dino weight, dino diet, dino user ID. So all of this new data will be updated in the database for that particular dino ID. Okay, so that's what's happening in our handler. So that completes our entire project. I've kept a Docker file for you in case you want to use it, and I've also I also kept like a sample .env file for you guys, and some SQLX data.json in case you guys want to use it, but everything else is quite sorted. I'm sure you have gone through the GitHub project GitHub link where I have put this project. You can feel free to clone it, and do share these videos with your friends, guys. Do share this playlist with your friends. We're doing a lot of awesome stuff. We're building a lot of awesome stuff that can help a lot of people. So make sure you spread the word. Thank you so much for watching, guys. Don't forget to subscribe. I'll see you in the next video.